27 years, and I think the institution has given me every opportunity to explore my own offerings. The institution has become part of me, and I have become part of the institution. So it's a synergy which I want to acknowledge. And then I also want to acknowledge Dr. Nankumar. We, coincidentally met on a kind of same interest platform recently, and I was sharing to him the work we're doing. Though he has an attention on water, I was trying to convince him that sanitation is more important than water. And we've ended up here today, where I've got this opportunity and the privilege to share a talk on my sanitation journey, over the last 27 years. So, I also want to kind of pay tribute to Dr. Pathak from Sulab. He's one of the global stalwarts that started to raise the agenda on sanitation, and sadly, he's kind of passed away recently. But my connection with India has been quite strong and long. I mean, in a way, my mind and my thinking has been curated by many Indians in my early years while serving on international platforms like Ashok Chatterjee, if people remember, in the water and sanitation decades, to people like Nafisa Barot, who is the recent IWA awardee, to Dr. Sunita Narayan from CSE India, where we continue to have a very close working relationship. And then also, one of the leaders in the wash sector from India, Dr. Gauri Shankar Ghosh, who together with him during the years of the Water Supply and Sanitation Collaborative Council with Dr. Darren Saywell from the UK, we had the privilege to actually push the boundaries at the WSSD, where we managed to influence the sanitation agenda and got sanitation recognized as a target. So that has been the kind of journey that I've been through. And I'm going to take you through this new journey that I've kind of embarked on. And it stems from the kind of challenges we're having deep down in the South, around where we are mostly wipers. And, most of our informal low-income systems are pit latrines, or ventilated improved pit latrines, and it's dry systems. And, if you look at it, it's also influenced by, the open defecation challenges, which I was exposed to in India, that, for 100 to 200 years, we can't find solutions to sanitation. And this kind of also added to the pathway we are going around sanitation, because it continues to breed inequalities in the world. So where you're born in this world determines the toilet you get. So there's always this divide between the rich and the poor, where, when you look at somebody that is a little bit rich, you give them a flush toilet. And if you look at a poor people, you just automatically, give them a poor flush or a pit in the ground. And one of the big problems that had been there is the sanitation technology entrenchment. Okay, and it's been the Achilles of this problem of inequity and low progress in sanitation since the time of Queen Victoria. Okay, and people think that we cannot disrupt it, but we've brought in two big generational changes around sanitation in fecal sludge management and non-sewage sanitation. And you'll see I'll be talking a lot about how we're bringing about this disruption and how it's beginning to serve, society much better. But, we fighting this big dragon called the gold standard, and it's the flush toilet and the flush vision in the developing world. and the developed world, that's the aspiration. Even if you don't have water, the aspiration is you must transition to a flush toilet. And policy, processes, all the kind of engineering teachings, etc., we get is directed toward the gold standard. And nothing is changing. So this binary engineering approach, where when you look at an urban area, it's to install sewers and wastewater treatment plants and flushing, and in rural areas, look at poor flush, etc., is what has been the kind of norm around how we've been responding to this engineering challenge. So against this background, we started this disruption because largely in the South, our problem is that we started to see a whole escalation attention to sanitation after the WSSD target was announced. And we've seen this big rollout of on-site sanitation, largely in the form of pit latrines in the South. And I know in India, it's poor flush. And recently, you'll have just emerged out of a really rocking, groundbreaking initiative of the Swachh Bharat. Okay. So the similar kind of trajectory, we saw a whole lot of the civil engineering initiatives moving out where toilets started to be built. Okay. And the problem is no one has done any scientific research on understanding what happens on an on-site sanitation system. There were, to my teachings and learning, 5 wise men that in the water and sanitation decade sat back and said, how do we deal with the problematic water and fecal orientated diseases in the developed world? And immediately, the transmission pathways, needed to be interrupted because it comes from your gut, it comes from your feces. So they kind of hypothetically design the on-site sanitation system or pit latrine, whether it's a poor flush or a dry sanitation system, as a health intervention to break the transmission of your common pathogenic diseases that cause diarrhea and other illnesses. And the hypothesis was based on wild kind of assumptions and science that if it's contained, it would decompose, etc., etc. But that's not real. No one has really delved deep into the science of it. And when we were confronted with this, we went into the science to understand what is happening in pits, because we've been designing it as engineering designs and designing it for 10 years, and we're seeing them filling up in 2 years, 3 years, 5 years, etc. There was all these kind of inconsistency, and it was a time bomb waiting to happen. Okay, so we went on this whole trajectory in a 3-pronged approach to understand and determine the science of what was happening in terms of on-site sanitation systems. Then we also started to look at desludging and pit emptying techniques, because it comes, the whole on-site systems come from a very missionary kind of intervention, where a lot of missionaries went and they did 1 toilet or 2 toilets. Now we're scaling it up as a service in both urban and rural areas. So emptying became a big problem because we've never emptied pit latrines before, and finding beneficial uses for the sludges, and then also designing the superstructures much better and lighter so we could access these pit latrines, etc. So we went into this whole area of science, etc. And I'm just going to share one piece of science because it threw out this what you would say misconception that pit latrines compost and etc. And we've had long debates with Sulab on this, because they went around to say, look, it's compost, etc. And we said, no, we have the science that now proves that pit latrines do not compost. Okay, what you get is a whole mechanical activity that what you would say contains and compresses organic matter to become stable, but still remain organic and still remain infectious. The pathogens, etc., continue to become inert for a time till they expose to environmental conditions and they hatch and they start growing again. And we found that with Ascaris, which is the marker for safety. So we've shown that in dry pit latrines, you don't get composting. And when you empty it, you're not going to get compost. You're going to get raw shit that is stabilized. And in pore flush systems, it's a little bit more distributed because of the water and the oxygen, but you get a better stable organic matter. That's also not really safe if you are servicing these systems in communities that have a continuous pathogenic pattern, that they're not completely disinfected and clear from any of these prevalences. We also looked at, additives, because we get a lot of guys coming around selling all these fancy little powders and mixtures and liquids to say, throw it in the pit latrines, everything disappears. And the science around that also, prove that nothing happens. And I also now want to recognize and give credit to Professor Chris Buckley, who, enlightened the science around sanitation issues, etc., over the years that we worked with him from the University of KwaZulu-Natal. And Chris came up with a very simple scientific formula. He said, this is about energy and mass. If you put energy in, you should be able to get energy out, and you should be able to give me a calculation for it. So if you tell me it's composting and you put a carbon item in, you should be able to capture what the reaction is and tell me what the energy release is, etc. So I know what is happening in this organic process. And many, many people could not answer that when it came to dealing with fecal matter, etc. So over the years, in engaging and also, great events like Swachh Bharat, etc., is the problem is we've seen, and my personal experience is that whenever we deal with a new challenge like sanitation, okay, there is a lack of sanitation competency. We have a lot of dam builders and wastewater specialists, etc., that are thrown to deal with this problem, but they have a cooking clue about what sanitation is about, what the science is about, what the process is about. The second thing is that most, public initiatives are very technocratic in approach. It's a civil engineering exercise. It's how the concrete is laid, how the contracts are rolled out, etc. No one really does understand sanitation. It's all about, putting the cement and putting the bricks and the mortar, and the public service is a good engine to roll out large service programs, etc. Like we saw in Swachh Bharat. I mean, it's wonderful. The toilets are built. Are they working? Are they being used? Are they functional? Are they effective? No one cares at a public level. The box have been ticked that a toilet has been built. And we have the same kind of interpretations in my part of the world. A lot of novel policies we write are interpreted as engineering guidelines. So if we say minimum, they make it the maximum. If we say something else, they make it an engineering guideline. So in South Africa, we also say a minimum VIP. That is the standard now. So any poor person you see, you give them a hole in the ground. Not looking at the consequences of the environment, etc. The next is that the lack of innovation in approaches. I mean, there is no in-between alternatives to sanitation. And the psychology when it comes to poor people is give them the minimum and the least. Because the intention of an official or an implementer is you want to deal with a problem that becomes invisible. Okay, and sanitation doesn't become invisible. I use the term shit flows. You can't make it disappear. Until we find a technology to make it disappear, then we found the kind of solution for the world. And the thing is that there is a lot of money. People throw a lot of money to to this problem, but it never goes away. So it's better to have a longer term view and a more integrated approach. And one of those is that the poor people in this world do not have a sanitation market. That's why 2 billion people do not have access to sanitation, because there's no market. You're waiting for public programs. There's no incentive. So, the problem continues to persist. Now, as we're traversing over these last 20 years, the sanitation pressures start growing, okay? Climate change, water stresses, aging infrastructure that is there in the developed world, population growth, and rapid urbanization. Now, we've seen many recent cases of Cape Town crisis. We've seen the Chennai crisis, etc. And a lot of attention go to water to say, hey, it's a water stress. But, bottled water can be shipped and made available for people to drink and wipe. But imagine if 12 to 18 billion people get constipated or get into the environment and start doing open defecation in a city environment that is so dense. What would be the consequence of that? So I keep reminding people that in the modern challenges, it's not a water crisis, it's a sanitation crisis, because imagine people in New York going into open defecation. It's really, really bizarre. So those are the kind of things we're seeing happening in the space. And, we keep debating, like I said, and learning from Sunita Narayan, that reminds us that, rapid urbanization, population growth are the bigger problems we need to see in the modern urban world. And climate change is just going to exacerbate the challenges because of the demand for water and infrastructure. And the problem and the planning paradigm at the moment is that we have this one-track mind of bringing waterborne flushing systems. So we're going further and further away for a highly resource-intensive, capital-intensive solution of finding water to produce pollution. And then we struggle to manage pollution because we don't have STPs and we don't have all those kind of things. And there's a perpetuate growth in inequity and unsustainability in the developing world. So the poor continue to be marginalized because of this paradigms. And water scarcity is going to make that circumstance even worse. So we need to have a new way of looking at this. The story that we're getting into is the story around human waste, okay, which when you unpack it, okay, it's just 0.6 to 2.6 liters of urine per person per day, okay, and it's about 149 to 243 grams of what you would say solid matter, which 92% of it is moisture that is trapped in a carbon listing. And this is where the opportunity sits, is that this is a very small amount to deal with, and we haven't used the engineering and the science to tackle this, but we've been subjecting 6 to 9 liters of fresh water, treated water, to move this, because it's a behavioral thing from the Victorian times, downstream away from us to be treated in highly energy intensive systems, so that we can put this pollutant, after it is treated, back into the environment safely. And 90% of the time that doesn't happen. I'm in a country where 80% of our wastewater treatment plants do not comply with the standards and the regulations. And you can have a look at your own country and you'll see the similarities that, these things are challenging. needs revenue, it needs resources, it needs capacity, it needs electricity, and many, many systems do not comply. A little while, my apologies. It should come back on. So sorry about that. If I'm back on, somebody just let me know, because I just had a power failure, which is quite.
No, you're
common.
audible. Yeah, we can hear you and see you. You could continue.
Wait. So I'm saying that, we're subjecting all of this, and it's really madness in the modern world when we talk about water security and water stress, to keep flushing this water away. And on average, if you take the bath water, the wash water, the kitchen water, etc., we're subjecting about 200 liters per capita per day to move human waste that is a very small fraction. It's less than a cup at a time, downstream, etc., and we create this pollutant. And we had to look at this. So this is where this journey started, to say that, look, let's not look at human excreta as a waste. Let's look at it as a resource of global opportunity, and maybe we can change the whole trajectory and pathway, and talk about feces and urine in a better way. And through this process at the Water Research Commission, we conceptualize this term called sanity. Okay, it's the Sanitation Transformation Initiative. It was about changing this pathway in terms of variety of areas, from a technology, from a policy, from a research and development, and firing up a whole lot of new pathway around this. So, the sanity concept is embedded around variety of pathways. One is around an industrial platform, around fixing the policy toolbox, around creating markets for new sanitation, by introducing standards, bylaws, building regulations, designations, firing up a whole pathway of a suite of technologies that are tested and evaluated, creating business toolboxes to allow financing and capital listing, but also then, capacity building and starting to prepare a new cohort of sanitation specialists. Because like the digital world, it's transitioned to a new cohort that is not civil engineering based. They might be process based, or other discipline based. So sanity was this kind of holistic approach that was driven to disrupt this whole sanitation space. And the model started to evolve, and the thinking started to evolve on the back of that, we're moving away from this old sanitation paradigm that, what you put in is human waste, and what you put out is a pollutant, in the form of fecal sludges and those kind of things, to a paradigm that, you're putting in a resource that is coming from a human being. You have a toilet system that harnesses this resource, treats it, and produces valuable products like biochar, fuels, and fertilizers. And if you look at the potential of human waste and what it can produce, okay, from a resource side, 1.5 liters of urine has a lot of urea, nitrates, organic ammonium salts, etc. Feces is a remediator. It's about 0.4 kilograms, and it's got energy potential in it of 1.6 joules, through an oxidation process, if you know. So there's a lot of potential in that. And when you sit in this disruption and you look at this is how cities transition, from a water supply, sewer drained, till we have in the developed world, all those kind of things. We then start saying that we have problems. How do we become a water sensitive city? that is much more secure. And, for the developed world, rather than going through this whole trajectory, we could disrupt and leapfrog, through a new sanitation paradigm of having new solutions that are non-sewage, that we don't have to have all these problems that the West have around aging infrastructure and those kind of things and pollution and those things. We can leapfrog innovation like we have done with, mobile technology, etc., straight into a water-sensitive city paradigm. So this is where, for the developing world, this opportunity sits. And the developed cities can also transition this slowly as their investment starts deteriorating. So all our work that we've been doing from a scientific stuff, was picked up by the Gates Foundation. They came here, they listened to us, they looked at our science, they asked us where with this big opportunity. And Bill himself came to see the problems on the ground in South Africa, and having meetings with a number of key people asked us, his teams asked us, and we said, look, if you're going to solve this problem globally, okay, for the poor, you have to reinvent the toilet. You have to bring an aspirational solution. So, Bill was just starting his foundation, and one of his 5 focus areas became reinventing the toilet. And he put $100 million out there to drive innovation, to develop the aspirational solution for the future, okay, that destroyed all pathogens on site, didn't need a sewer. So everything needed to be treated and managed at a household level, and possibly generate as output a resource with the least amount of electricity requirement. And then the bigger challenge, that to make sure that it meets the needs of the poor, that the operation cost would be $0.5 per user per day, as a business model. So this was launched in 2012, and we've been a big part of the development. We're one of the labs of the partners of the foundation, driving this next generation of sanitation solutions, and responding to those challenges. And I'm not going to go into the detail of this, but a set of systems that apply at a household level, at an apartment level, but also respond to the current systems that we have from a fecal sludge management perspective. Now, people might not know, we pioneered fecal sludge management in South Africa. I think India had leapfrogged it into policy and practice. Today, India is, one of the leading centers in the world where fecal sludge management now has become what you would call a norm, a standard practice at a municipal level, because you're dealing with so many what you would call septic tank systems that are not connected to sewers, etc. And it's closing the gap around a pollutant pathway that is contaminating a lot of rivers and streams and etc. in India. So that, has taken off. And like I said, we pioneered it in South Africa. We're still struggling to scale it up. India's, introduced policy for FSTPs and management and programs, etc. And that's great. The other area is the non-sewage, and I'm going to share with you that to deal with all of this FSM and the non-sewage stuff, etc., the new product categories and business opportunities evolved around the household toilet. Okay, like I said, off-grid, no pathogens, appealing, aspirational, no smells, no insect, to what we call omni-ingestors. So those systems that can be taken to deal with fecal sludges at a decentralized level. And then the larger omni-processors, where we could connect many households and provide off-grid sanitation, in a smaller region or a smaller community, very decentralized, and largely treating black water that can be recovered and reused back for flushing and that. Now, a little bit of the science again. Over the 12 years, We've been playing around with technology and processes. What we're finding, from the first round of processes, from a science perspective, if you want to build a household toilet that treats human waste quickly, within 20 minutes, 30 minutes, in a batch system, etc., at a household level, the processes that dictate the efficiency are not biological anymore. Okay. Biological are the lowest of them all because they require too much time and control in terms of treating human waste. The new processes are physiochemical, in the areas of electrochemical around oxidation processes and dry combustion, or even incineration are the new technology pathways that can achieve that objectives that we set out. Now, I'm going to jump straight into some of the solutions we're seeing, and the first is we've been pushing the kind of the bar on redesigning the front end systems. Okay, most of the front end systems are between 4 to 9 liters from a water conservation demand management. But if you want to build a reactor in the house, one of the big new Achilles heel is moisture. So you need to reduce, because moisture means energy. Okay, and the binding moisture in human feces is so strong that you need a lot of energy to separate it, at a household level. So one is that we want to keep the moisture levels very, very down. So you'll see that we invented women's urinals so that, they don't use the toilet seat, and we can separate the urine and treat it separately. But we started inventing a whole lot of microflush systems. So now it's commercially available. We have 1 or 2 liter microflush toilets designed, on the principle of the pour flush techniques of India. We've now modernized it into a pedestal, and these are commercially available. And we're seeing a number of alternative innovations starting to emerge, to the one called the EOS, where it's got a very smart urine separation system, not like the Swedish one, much more convenient, where we can separate urine and the feces and even go down to a lower flush of 1 liter. That helps us to make the back-end reactors very, very small. But there's also dry systems, in very, very challenge areas where there's no space. So this is a biodegradable plastic bag system where you can capture, it doesn't mess, it doesn't smell. And, for a small informal settlement or a shack or a slum dwelling, this can be pushed in a corner after you use it. And it allows individual sanitation solutions and experience. It's possible now in those areas, and you're able to collect this material in its good biodegradable form that you can then harvest and create a whole circular economy around the urine and the organic fecal matter. So this is one example around how a dry system that's modernized, that is much better, that's aspirational, can appeal to people in informal settlements, because you're able to bring a solution that is appealing. And then you get what you would call the decentralized systems, and we have these already working and tested in South African informal settlements. These are the closed loop systems. One of them is the clear system from China that we've adapted and localized, and it's treating black water from toilets in an informal settlement, and it's treating it to a level where it meets a drinking water quality standards, but we are reusing the water for flushing. So in this area where there is no water supply, once we fill this up with water, it works itself, throughout its operation. We don't need to bring more water in. It's completely off the grid, closed loop system. And there's another one from USF, University of South Florida, called the New Generator. And the New Generator also harvests some of the urine and material to generate electricity that can be put back into the community as well as byproducts. So we're starting to see these evolving to, more smarter septic tanks that also, at a household level that provide closed loop opportunities. So, but also harvest gray water in the process. So it's closed loop and it can take you off the grid in terms of water, in the future. But then we're seeing a lot of regional technologies for treating sludges emerging. The LADEPA is a pelletizing system that's also being used in, places in India, in different versions of it, to biogenic refineries that also, treat sludges. And recently, in our own stables, we've come up with a commercial version of a hydrothermal carbonization technique that works across all sludge ranges, both municipal and, but then also technologies for harvesting urine, harvesting phosphates and nitrates. It's a diamond reactor. So in a shopping mall, we have this place at the bottom because most people in a shopping mall urinate rather than defecate. So it's a very good input source to create a small industry around producing phosphates and nitrates while treating urine. And then what we're starting to see is the first R2G2, as the foundation calls it, household reinvent the toilets emerging. And you'll see we are putting them through tests in real life situations and real life households. And we at the point where it's ready to be getting into the industrial platform to be rolled out, because we didn't want to just put it out there and live with the consequences. We wanted to make sure that all the consequences are dealt with. There will be other consequences of behavior and those kind of things, but technically, we would put out a product that is aspirational, safe, and we'll know that it'll work 95% of the time. So this is happening in our backyards, in our laboratories in South Africa, in communities where we're testing some of the technologies. And this whole non-sewage pathway has opened up this whole interest. I mean, the pipeline is growing. It needs to grow much more diverse, but we're seeing greater innovations emerging every day around this non-sewage sanitation, journey. And the big players are getting involved as well. So, this is the versions being tested by Samsung, who's thinking of moving into this future as well. So they are making it aspirational, and that was version 1. That's version 2, and this is the future version they contemplating of once they roll out. So if you're thinking about non-sewage future toilets, that is what the little box is going to look like in the future. Okay, like a super air conditioner or a microwave or an air fryer. So it's working in the direction of an appliance of the future, and it's going to disrupt this whole sanitation paradigm that we've been stuck with. Now, I want to touch a little bit about the circular economy aspect as well, because I talked about it, about the potential, but once you go off the grid non-sewage, you're disrupting a public service model, but it opens up this model for a new economy where there's services offered, there's new players, there's new enterprises, there's new offerings. So there's people working on sensors at the moment that will tell you your health for the day, measure your urine in the toilet and tell you, what's your glucose level, what's your, what you would call the protein levels, etc. So that the modern sanitation systems are going to also manage your health and your, what you would say, your overall health, but other aspects around the resource. So there's a whole industrial opportunity that this new non-sewage sanitation pathway is going to create. Now, we in South Africa are far down the line globally. Like I said, we were one of the kind of countries that led the initiatives around it. So we have a program called SASTEP, the South African Sanitation Technology Enterprise Program, that's living this strategy around sanity. And we've been working on changing national policy. We've developed an industrial policy action plan that will manufacture these toilets at large scale. We're the first to adopt the sanitation standards for non-sewage, the 3500, ISO 3500. We're bringing in a lot of regulation, bylaws, building regulations, all being adopted. We need the signal from government. We need a Swachh Bharat for non-sewage sanitation, where government sets the industry, and sets it in the direction that becomes the first adopter that, starts this market to flourish and grow in the country. And we're starting to see that happening. It's a little bit slow, but yeah, it's going to happen. Now, people always ask, what is the opportunity? I mean, in India alone, it's $400 million a year. The global figure is about 8 billion, I think. Yeah. If you look at different countries, it's a big, close to about an $8 billion industry a year. Okay, and if you look at just closing the gap on the 2 billion people, the other 6 billion people of us, we don't have the right solution for the future. So we become the net beneficiaries of this initiative that started on the back of serving the poor, that moves us into a sustainable pathway in the future. And somebody asked the question, but what will happen to this industry? And I keep reminding them, we'll never run out of poop. We can't run out of poop. As long as people are eating and producing, the potential is 3 billion kilograms every day. Okay, that's a lot of raw material to create an industry around. So we have a little joke around, the world gives attention, the Fortune 500 or the Fortune magazine gives this attention to, the unicorns of the world. And we've termed this coin that Sanicon. Can we build the first Sanicon? The industrialist or the entrepreneur that's going to break the 1 billion barrier on the back of sanitation. And my previous boss says, let's think brown, okay, because there's gold in it and we can mine the gold. And yeah, so that just brings me to the end of this journey that I've been driving and curating over the last few years. We're busy putting out a training course under the African Cities Lab. It's a MOOC that would be going out soon, that people can join. I don't know whether it's going to cost or it's free, but the potential is there to get into learning more the technical and nuances of what we've been doing. And just to end to say, for me, the future is exciting. My own kids now with mobile technology and sanitation are spending more time in the toilets, because that's where they get their privacy and that's where they get to do their Facebooks and the WhatsApp much more without disturbance. So sanitation and technology in the IT space are moving together. And it's where the convenience is going to sit. Thank you very much. Thank you, Pooja.
Thank you so much for the exciting. Sir, can you hear me?
I can hear you, yes.
Yes. Go ahead, Pooja.
Yes.
Go ahead, Pooja.
Okay. Sir, meanwhile, we would like to read out. Miss Yolanda asks, does this mean the wastewater treatment plants will become something of the past? How will this then influence industrial wastewater?
Well, look, if you look at the trajectory, many industries are now beginning. Sorry, can you hear me?
Yes.
Yeah.
So if you look at the industrial platform has already transitioned to a zero effluent environment. Okay, they're far ahead in this game in terms of climate change, in terms of the green pathways, etc. So many industries have already started to not produce pollutants anymore, and recovering a lot of those opportunities. So, BMWs, etc., all decentralized, and they're not, putting out these. But the second thing is that policy can enforce that all industries don't produce wastewater anymore. They do recovery and reuse at a decentralized level. Okay, so that's the one way of looking at how you can move industry out of the space, and I think they're already in that direction around cleaner production, zero effluent, etc., and they all global norms for them. On wastewater treatment plants, I mean, if you look at the storyboards in the developed world, they're really thinking deep and hard, because to replace a wastewater treatment plant that they built 100 years ago is costing 50 times more in today's terms. And those revenue streams do not exist. Greenfields are easy. So, of course, if we can get wastewater to become obsolete, it would be great, because we are now eliminating this big headache we have called pollution. We spend so much of energy trying to keep cleaning water to put it in the environment, and there's more contaminants coming. All these emerging chemicals, phenols, PCs, all this stuff are becoming problematic, and we're not able to monitor and treat them through this conventional system. So we're putting out more cocktails in the environment. So it's better we eliminate those pathways. I mean, if the future, if we can start designing cities, etc., to become non-sewage, that we have grey water systems that treat grey water and reuse it. It's easier, it's cheaper, it's much more beneficial. Okay, and we don't have to deal with all those cocktails anymore. So there's work. It's not Professor Karthik Chandran from Columbia University is doing a piece of work that is modeling this future without wastewater on the back of non-sewage sanitation, and he's showing the kind of cumulative benefits it would bring, to environment, to societies, to energy, and many, many factors. I mean, imagine that you don't need big sewers. I mean, Italy is struggling to replace all its sewers. It's so dense. They really thinking about the non-sewage pathway as a norm into the future.
Thank you.
Moving to the next question by Mr. Arvind. Activated effective microorganisms have shown promising results when administered at a decentralized level, and not at the point like water bodies or landfills where accumulated sludge matter solidify much more than they are at sewage chambers or sanitation pipelines. They are cheaper, easy to administer, and no complex machinery needed. They may not give potable water, but they separate the sludge matter and other effluents much better. Any thoughts on this?
Yeah, so I'm not shooting down additives and all these new products that are coming. I think the science is growing on this area, and people are producing smarter and smarter cocktails. Okay, and it's not new. I mean, in the industrial areas, we've been designing smart, microbes, etc., to treat spillages in oil and those kind of things and chemicals. That has worked effectively. But we've seen cowboys in the past that people take a little bit of knowledge of science, make a cocktail, and come and tell you that yeah, see how it works. And like I said, my question to them is that, can you write me the energy balance equation on your product? okay? That you went in there, you took a sample, you put your sample, there was an energy release, you could quantify how much was released so that you can convince me that your product worked because it was treating something in that pollutant. You know, seeing, a lot of these people come and say they throw a bucket in there and they think that there's many dynamics happening in a big pond of water. Okay, there's currents, there's temperatures, there's all sorts of stuff. How can you scientifically tell me, exactly that your product is functional? So I'll give you an example on the pit latrines. People used to come with these microbes and they would mix it in water and add it in a dry pit latrine. Now, as soon as you add water, you're filling up all the voids and you're losing up this material. So straight away, the voids will drop and the material will fall. Now, to a layman, they would say, "Yeah, look, my product worked. In half an hour, it dropped so many centimeters." Nothing happened. It's just, normal mechanics. When you add water to voids, it collapses. So you need to be aware that you need to, if someone comes, apply the right scientific protocol. So many of these systems we've done control, we've created a technique where we can control the reactions from an energy, and we measure the energy release to give you an accurate answer of the performance of these products. So I'm not saying they work and they don't work. Like I said, there are products purposely designed in the industrial space that work on spills and those kind of things, and they've proven to work. But if people come, they must be able to produce the scientific evidence, not just say my products work. Because every water body is different. The dynamics in a water body is different. And it's the same with wastewater treatment plant. I mean, if you take a design from Europe and you put it in India, it won't work straight away. A wastewater treatment plant takes 10 years to optimize. Because as you get to understand your influent qualities and systems and all that stuff, you keep changing and making the system more efficient. But I've never seen a wastewater treatment plant on the first day it starts working at steady state, treating effluent at 100% efficiency. I've never seen one. If you find one, I'll change my views.
Yeah. Uda, there are a couple of questions. You can take them on. I think Mr. Yolanda.
The next one by Yolanda also answers. You answered her next question as well. Who will be monitoring the quality of effluent? I think that's where we were getting at previously also. Next question: will these systems be more affordable for low-income earners compared to current systems?
Yeah, look, I'm not going to lie. Okay. These are modern systems. They're using modern technology. But, industry is a different animal. As you scale up, the cost comes down, okay? Because the manufacturing processes, at scale becomes more affordable. So I will give you the answer in a different way. When the first LED TV was developed, it was very expensive. When the first mobile phone was developed, it was very expensive. It was, only the rich that could afford. Today, even my domestic worker owns 2 cell phones because, industry was able to bring the offering, either through, in fact, my domestic has a better handset than what I have. Okay. And there's variety of marketing and financial instruments that industry has developed to give her that aspiration and satisfaction. Okay, so I wouldn't look just at the cost, look at the impact, because if you give industry a chance, they will make it affordable. So I'm not saying that the new technologies are going to be cheap. Okay, mobile phones are not cheap. They're a very advanced instrument, but the market, the industry, etc., makes it affordable, and that is what I would see happening around this pathway. That as the demand grows, as people might have 4 of these toilets in their house, not one, because some of us in the modern world where we live, I have 3 LED TVs, maybe 4 even, one light, because it's affordable now. I have 2 or 3 computers, for my kids and tablets, etc. So
But Jay, I want to just check. I want to ask you on this topic because it's also been, on my mind about the affordability of these solutions. And as you rightly said, with scale, the cost would come down. But if you were to look at LED TVs or mobile phones, they actually filled a void at that point of time. There was no alternative. They were not trying to dislodge something which is already in the market. Whereas here, my concern is that already you have expensive systems for handling wastewater, at least in the cities, developed countries, or even in India in many parts. So this has to compete with an existing system for whatever it's worth. That system is in use. How do we then incentivize people to shift or change? Would saving of water potential be a motivator, or will it be some other economic interest that there is a value that comes out of it, and therefore people would want to switch? How do we make this a scalable proposition?
Well, Nankumar, this is where the aspirational thing comes in, okay, and the behavior change associated with it. I will build a lot of synergies. I don't know in India, but maybe I'll take India as an example as well just now. But in South Africa, in the slums, when people put up slums, and they get what you say, artisans to put up the shack and those kind of things. Now, before, shacks were just built of the metal sheets, etc. Now they come with windows, and the standard attachment is a dish, a satellite dish, or a mobile dish, whatever you call it. Because people don't like government's transmission of TV services. So the alternative market has created digital TV that is cheaper. Okay, so people are now using that service much greatly in the informal settlements because they're getting better products, they're getting a digital signal and a better offering. Now it's the same with India. If you take what you call the TV, cable TV. I mean, it started off, for the rich, but technology and product and this thing, now everyone, even in a slum area, everyone's got the service. It's a service, and it's affordable. So I'm saying, don't limit what can happen. And somebody asked the question that in the future I might not buy the toilet. I just might buy the service from a toilet provider. Okay, so it comes as a unit, like many other things like my fancy BMW, etc. Because nowadays I can't change the oil in it, so I buy a service package and I just drive it in, and it gets changed. So hopefully this technology will evolve. That's why I said there's a market that is there that I can rent to use it, and if it breaks down, they'll swap it or they'll this thing, because it's not a big box. It's just taking and it's like plumbing services. I mean, if your toilet is faulty, you call the plumber and he fixes it. You don't fix it yourself, the complex stuff. And that industry will evolve. And like I said, that the renting and etc. would become attractive. It would become cheaper because the scale is going to be up, the financing is going to be up. And that trajectory is quite normal and quite kind of relevant in all essential. at a
I
household.
want to check with you. See, in India, there are many places. I'm looking at the rural sector, the villages where toilets, Swachh Bharat Mission has put toilets or may not have put toilets. They are not being used. End of the day, people do not have an alternative to open defecation, let's say, or even if they have a toilet, they don't have water. So, is there a way to use, let's say, CSR funds or some kind of foundation money and start with these systems in a village where there is no need for water to maintain this? It may seem like a luxury, it may seem some high tech stuff, but it actually solves a problem. And it may actually attract people because they find it very convenient, smell free, and there is some value that comes out of it. As you said, it's a raw material that goes in, and something of value comes out, whether it's a biochar or a fertilizer or something. Because at a household level, people may not know what to do with that biochar or a fertilizer because they have to find a market for it. But at a community level, there could be somebody who takes these things and makes value out of that. Is there a potential for India to experiment with this technology or anything that is affordable just to prove a point? And there is clearly a social benefit, there is an environmental benefit. Funders would be willing to come forward and demonstrate or participate in this. And over a period of time, we could even incubate a few startups who are innovative around what kind of a revenue model works. Instead of, as you said, owning a toilet at home, some toilet just drives in like a car, and people go sit in it and then it drives off. I don't know if something like that is feasible, but what do you think India can do with such a technology offering today?
So, I use the term leapfrogging, okay, and you have to see the context. And I forgot to mention that, I spent 5 years doing my engineering in India before I moved to the UK. I'm a graduate from VRC in Nagpur. So I lived there and I know what the situation was. I lived in an apartment that I flushed the toilet, whether it was 4 flush, it flowed down to the little gully down the road. And there was no sewers. There was all this development, but people were putting it out into the environment. So cities just smelled, and people don't like it. Many people don't like it. Now, I use many analogies, around even hotels and etc. In big hotels, all have backup electricity in India because it's not reliable. Even in Bombay, you can't get water. Hotels like Taj ship in gallons and gallons of water, every night for the guests. So you can change that trajectory.
Yeah.
I mean, even, if this hotel can transition to a non-sewage potential, it's a huge saving. So to answer that question is that you need to have an industrial, what you would call foresight on this. It's not going to happen if government doesn't come and becomes the stimulus. Now, and we learned a lot from the Swachh Bharat. I mean, the stimulus that the Swachh Bharat gave, India could not achieve in the last 40 years. They done in 3 years. So there's that kind of signal that if at a national level, government says, and they start looking and it's a many social and the behavioral thing. Even in Africa, toilets are built 5, 6, or 10 meters away from the house because we come from this history that these things smell. Okay, so we can't attach them to the house. But then we talk about women's safety. We talk about, and I've lived with my friends where, women don't go out in the night to toilets, even if they're desperate and those kind of things, because of safety and security. Why can't we bring the toilet, into the dwelling, and change that behavior? And technology can create that behavior change, and change the trajectory so that aspiration, that ownership, etc., starts evolving and more of that would happen. So those are the things, if we keep perpetuating what I call a very colonial mindset, It will remain just like that. I mean, and that's the thing. It's from the colonial systems around having toilets away from this thing because they smelt. But in this modern world, that convenience is not there. The safety issues, etc. So we can change that by bringing products that are aspirational, beneficial. People will pay for better service. We're seeing that in many of our informal areas. And somebody put the question, you cannot create this industry without public sector, whether it's local government or national government. They are a key equation in this, to stimulate and enable the environment. They're very key in that.
Sure. Okay, Pooja, any more questions there?
Two more questions. One about how confident are you on self-maintenance of these toilets as treatment happening at the toilet itself, as it is the main activity, and it'll create a havoc if there are any breakdowns.
It's a very good question. And, we've been having all this energy blackouts. So sometimes the water is not even flowing because the pumps are not working in the reservoirs. So there was a period where for a week we had no water. I couldn't flush. So I had to go to the swimming pool and fill up little bottles and bring back so I could use the toilet. So a sewer system is not free from the same circumstances. When you don't have water, you cannot go to the toilet. Okay? That's the first thing I want to clear. So there is no system that is completely maintenance free. Whatever it is, all technology requires O&M. Now, I'm not saying that this is a maintenance free, solution. No, I'm saying that you have to build the ecosystem and the core to service these technologies. They're not, there's physiochemical processes, there's incinerators, there's pressure things, etc. in it. It's like your air conditioner. I mean, people don't strip the air conditioner when it's not working. They call the technician. And there's a network of technicians there to service the air conditions. So you have that industry that people buy air conditions because they have be able to be serviced. But nowadays they're getting so cheap that when they break down, you can just replace it. It's cheaper to replace it. You don't fix it. So this is how industry will evolve, and I'm seeing that potential, in that, that as we scale up the efficiency of the marketplace, the servicing, the costs, all of that would start normalizing and making it more appealing. Okay. Nankumar asked a big question because where we're sitting at the moment as local government, etc., their issue is where is the revenue for us? Okay, because at the moment, wastewater treatment and sewage and water is a revenue source for them. And if people use 60% less water, what's going to happen to their business? So those are the hard questions we're trying to fix in this process of answering, because of course you don't want municipalities to die. They're always there to afford regulation and those kind of things.
But at the same time, I feel that the same supply chain system, which is already well existent, can be tweaked a little bit so that it caters to the current technology.
Yeah, look,
So
I'm not saying that.
Existence.
Yeah, I'm not saying that sewers and that one must be eliminated tomorrow. I mean, it's a 100-year investment, so you have to use it till it weans itself out. But all new areas, all greenfield areas, etc., should be put in this direction. I mean, I can't see why India is spending so much of money building STPs. It's become like a fashion, when it's creating all the downstream problems, and it's going to perpetuate that if these things don't work. So I would rather set the direction of decentralizing and moving non-sewage as a future and incrementally growing it. I mean, you're a big population. You'll have bigger challenges. So let the market develop and solve the problem for the country. I see Dr. Raval or someone had a question. You've been...
Can I come in, sir?
Yes, sir.
Yeah, this was really very, very interesting and impressive. But I'm not fully convinced. See, we are comparing sewage production with cell phone production. The whole world industry was under lockdown. Did we stop producing sewage? It's a biological process. You can shut down your automobile industries. You can shut down TV industries. This is involuntary process. Okay, the water recovery and other things that you have said, because if you see the human column, it is based on water recovery. Additional water use was a sheer stupidity of engineering of last 200 years. So we are trying to learn from the stupidity. That's not an achievement. It's a correction factor, and it has its merit. But sewage is basically a climate science. The machine and whatever the units that you displayed, they are very good, very impressive. But how will they sequester nitrogen and carbon? How the nitrous oxide will be either nitrogen fixation or nitrogen sequestration. It will be neutralized. And these are microbial processes. You are talking about energy generation from the fecal mass, but fecal mass from apple, which is a CN molecule with high ORP, the acetate is a C2 molecule, 2 carbon molecule, with a very low ORP. The entire electrocoagulation and all that you have said for pathogen elimination is fine, but redox chemistry is not addressed. And these are the finer issues where we'll have to, of course, open defecation and connectivity to the drainage system is a social advantage, but the sewage, there is no benefit. Any house with a drainage connectivity is not necessarily a sound sanitation. And
Yeah.
you very rightly said that you have not seen. I was deeply impressed with your this statement. You have not seen a single conventional STP working satisfied. It's a huge statement and wonderful. I salute you for it. But
So let me...
please, sorry.
I tried to stay away from the technical stuff. I mean, I forgot to mention, we're hosting the first non-sewage sanitation conference in October this year to talk about the science and the development. Now, I did not use the word in non-sewage sanitation sewage because we don't produce sewage. I said we are treating human waste, fecal sludges. Okay. So there is no, and I use the word physiochemical. So there's no biological process. It's an energy intensive process that all what you're mentioning, we talk now around, how much energy is required, how are the gases going to be captured, those kind of things. Because in those processes of oxidation and carbonization, etc., they're not biological processes. We're not even talking about microbes in the system. Where we're saying, how can we use energy to drive energy, okay, and eliminate or recover, products from human waste. So I don't want to get into that, area around the biological stuff because it's not about the biological. And I can spend the whole day talking to you about how the oxidation process works, etc. We're doing a whole conference now, beginning to share the science, of these processes.
But oxidation reductions is a coupled reaction.
Yeah, but it's not oxidation through biological processes. It's oxidation through energy processes.
Sewage is a biological product. I mean, as I see. And when I say acetate, I was talking about human waste only. I didn't mean common domestic sewage.
Yeah, but you see, sewage to me is a carbon item. And, you know, carbonization is possible through a heat pressurized process. It's, you know, so I can go into it, but hydrothermal carbonization can turn carbon, like human waste, into biochar. And that's what we do. So there's no biological activity. So I didn't get into the science for that reason. It takes a long time to go into stuff. But that's why I made the point that the modern future systems are going to evolve away from biological systems. Because I'm not saying biological systems don't work, but you need to control biological systems too much to rapidly achieve. You know, so with energy, incineration, and those kind of things, you know, I just have to control the heat, and in 30 minutes, I can get ash. Okay, and I can harvest some of the stuff from the ash, or I can put it to make bricks, or I can do stuff.
In that case, what is the wattage an ampere consumed for 400 or 300 grams of fecal mass?
Well, I don't have the figures at the moment. It's another slide I have, but we're trying to bring that down to something in the range of about 5 to 6 kilowatt a cycle. Because, you know, it's a batch system, so we're trying to see behaviors, and the reactors need to be a certain time, size, etc., that it doesn't become a whole room in your house. You know, it stays small. So, you know, we're working out that maybe there's like 10 defecations and this thing would create 2 or 3 liters. And then in an hour, this batch will work, and then the next batch will be ready. But in the modern world, you know, even in informal settlements, people, because of the economic activity, only spend about 8 hours a day at home. So these systems make sense.
Okay.
So let's take one last question.
Yeah.
Oh, I mean, two last questions. Is this project likely to be subsidized by the government as a part of public service?
Look, any solution in the world, you know, it's always imperative that the government subsidizes to start the industry, or the government becomes a partner in the process. I mean, I made the point that sanitation and drinking water is still a state competency. Okay. It's, you know, the private sector provides the support and the service. But, you know, national government and local government has a responsibility to ensure that public health is maintained. So they become an enabler in the process, whether through financing, whether through etc. I mean, if you look at our history, all the large infrastructure to secure water and sanitation is funded by government, not private sector. You know, they take loans, etc. So I don't see the state falling off this journey. I think that their role will become more prominent, more enabling, more regulatory, to make sure the technology meets standards, they operate properly, offer customer protection, all those kind of things that doesn't lead to, you know, public and environmental nuisance and consequences. You know, we have this big issue in South Africa because of the energy. We're using a lot of generators in that. And, you know, the fumes from my neighbor's generator is coming into my house. It's a health hazard. There's no regulation for it. So these are consequences of things that we plan for, you know, moving into the future. And it's part of what the state does to bring good bylaws and regulations and quality control, etc.
How will this system advance or assist water saving? Is it designed to save water?
Oh, it's the greatest invention in the world. Like I said, that if you take 60% fresh water out of the equation, you've halved the water problem in a city or a town. Okay. It means that your bath water and etc. you could go to very efficient systems so that you don't have to generate all this water to drive a sewer. All the other water uses was there to drive this 200 grams of 2 kilometers in a sewage highway. So you're not going to need those big pipes. You're going to, all those big pipes are going to become small gray water pipes. That's, so the future is quite disruptive, in terms of what are our big issues. I mean, Singapore could not put sewers anymore. They had to tunnel sewers to the bottom of the city. They built this big sewers because they could not replace all the surface sewers. So they built this huge tunnel and they just dropped all the pipe into the tunnel. So dense cities are going to face the same consequences at a certain point in their development. And rather than going that route, invest in this pathway. I'm not saying, once you invest, the market grows, the product selection grows, the technology diversifies, etc., etc. I mean, today it's not just Samsung that makes LED TVs. I mean, you get the big brands and you get 100 other Chinese and Indian and Korean brands you never heard of, but they're there, and their offerings are all different.
Great. Any more questions, Pooja? I don't see any.
No, sir, there are not any
Oh,
questions.
great, Jay. I think if I can sum up before Pooja has a final say on the closing of this meeting, Dr. Rawalji opened a completely new dimension, and I was expecting him to do that, and he did that, and he brought the microbial aspect to it. But that is when I also realized that what you're talking about is completely bypassing the bio part of the process and just using the chemistry or the physics of it to generate energy and materials out of this. So literally it means it's a production system. And so this is an alternative to the conventional method of treating sewage through water and aeration. At the same time, there are microbial and other algae and other methods of treating sewage, which are natural processes, which may take time. So there are now three systems, I think, coexisting. One is the conventional system, one is the emerging bio-based system, and the third is what you're offering is completely using the mass as a raw material for producing products and energy. So I see a great opportunity for all three, and obviously each will have its own space, and depending on the economical value that we can create, the market may move in that direction. From a sustainability point of view, you're saying that whatever you're suggesting is completely circular, in the sense the energy is recovered and there are no obnoxious gases or pollution to the atmosphere, and certainly not to the water bodies, because there's no water. And the byproduct benefit is that there's a huge amount of gray water that is available, which can be treated better and recycled. So all in all, it seems to be a very sustainable option. Technology cost seems to be still a factor, but certainly the market has to start somewhere, like the mobile phones and LED TVs did, and hopefully it will find its own, place in the future. So yeah, great.
Yeah, just to in parting, in India there's a number of initiatives. The BITS Pilani in Goa is testing some of the systems. Like I said, they're still testing it to get the operational things. IIT Palakkad is being developed as one of the scientific hubs for non-sewage sanitation. Warangal has been scaling up some of the omniprocessor technologies. I think Tamil Nadu and Telangana has kind of harnessed this opportunity, and they're starting to see it as a strategic intervention going into the future. So they becoming a key partner in shifting this direction. So there's lots happening in India, more on the south than the north. The north are stuck with FSTPs and STPs because they're close to Delhi. I think that's why. But the opportunity for India is quite big. You have a big opportunity, and it can create jobs, it can create an industry, all sorts of, and then there's a whole lot of South Asia to service. So I would see this, from like building cars as well, and exporting cars, that if India gets its head wrapped around the economic opportunity, they could become a net exporter of sanitation solutions after IT solutions.
So why not?
Can I come in for, sir? Can I come in for 10
Yes,
seconds? Dr. Bhagwan, there are some figures coming to my mind.
Yeah.
Say 1 gram of acetate, it's 1 gram of glucose, which is a C6 molecule. When incinerated, it takes 1.04 gram of oxygen.
Mhm.
And 1 gram of biomass consumes 2.06 gram of oxygen. So this incineration, how will it be green? And now sewage is from 8 billion, 365 days. Buying a car is once in a lifetime or once in a decade.
Yeah,
Sewage, sorry, please.
I'm not going to get into the technical side, but the processes of heat recirculation, etc., start offering all the efficiencies you want to get. So once you fire up some of these systems, because they're energy intensive, they generate heat and those kind of things, you're able to capture the excess heat, put it back, and reduce the energy requirements in the system. So, there's all sorts of things happening in this space. And that's why I said it's disruptive, because when we started examining the science in the early years against the objective we wanted to build an appliance of the future, the physiochemical processes were the direction we had to go. And it's not new. Thermal carbonization, pressure cooking, etc., industry has been using, on industrial processes for years. We're taking that knowledge and we're putting it into a little toilet now, okay, and making it smaller at a household level to treat a carbon mass. So we've got these toys already. Like I said, you can speak to the people at BITS Pilani. They can share with you more technical stuff, etc. I'm not the deep scientist, etc., on every process. I have a good understanding of it, but that's a better debate to have. And hopefully, this can become a topic for discussion in India, at a scientific level.
Sure. I think this is a good point Dr. Rawalji has raised. The discussion on the sustainability of it, we should reserve for another meeting. Maybe the users can give more data, BITS Pilani or wherever it is, so that we could represent the case better.
Yeah.
Certainly we should do that.
And just one in parting, the issue of costs. I mean, you have to offset it, that if you take away wastewater treatment plants and big sewers, which are very costly, I mean, a lot of debt is built up by government borrowing money to build that infrastructure. Okay. That subsidy can do a better job in making these technologies affordable to offset that and the benefit is the environment and and jobs and economy. So I tried to do 2-3 things in this process. If I had to talk about the toilet economy, it's a lecture on its own.
Yes, Pooja, I think.
Lastly, affordability to a pocket on one hand and affordability to the nature. Otherwise, it will not be sustainable. So how it is maintaining the second part of the side, that if you can throw some light.
Yeah, affordability is relative. We all are poor. Okay.
Affordability to the nature, because the temperature to break up acetate will have to be raised to 150 degrees centigrade. Now, all this data, I'm confused, so I'm asking. I'm trying to learn from you.
I can't answer that now because, like I said, I'll have to also absorb that question. But there's going to be emissions. We're monitoring the emissions. We're trying to calculate that if 1 million people put 1 million toilets, what would be those kind of consequences. But from what we're seeing, it's not going to be 100 times worse than what industries are doing, what thermal power stations do, etc. So, it's a little bit of some of the gases, etc. But I can't answer that now. We're still working those things out.
To add one more interesting circularity, any power generation depends on water availability.
Mm-hmm.
So either I consume water in the commode or at the power generation station. The amount of water consumed is, it doesn't change much. Because my thermal power stations or even nuclear power stations, that is why all nuclear power stations, they are at the seashore.
Mm-hmm.
And sulfur is something we cannot do without, because the whole biological system is formed of sulfur molecules. So anyway, I mean, what you have said is the answer for decentralized system, and we'll have to say goodbye to the drainage and capital incentive systems. Thank you, sir.
Thank you very much.
Thank you very much, Jay. Pooja, you can conclude.
Thank you so
now.
much, sir. Yeah, thank you very much, Jayant sir, for sharing your valuable perspective on sanitation and giving us more insights on this new technology. So far, I believe we were thinking as human excreta as being an end product, but now you have given us a new perspective to think about that as a beginning of some kind of a disruption to change multifolds of how we treat it. Thank you so much for bringing that knowledge to this platform. And we are very grateful that you accepted our invite and were a part of our Water Talks. We would also like to share the invitation of next Water Talk on more such initiatives and more such topics on every last Wednesday of every month. And next one would be on 27th of September. So I would request all of you to please stay tuned to our updates. And once again, thank you so much, Jayant sir, for being a part of this. And thank you all participants, especially Raval sir, for bringing about so many interesting questions and digging deeper into this platform. Thank you so much, and I'll take your leave now. Thank you.
Thank you very much.
Thank you. Thank you, Pooja.
Thank you very much. Thank you.
Thank you. Bye.